You probably don't know this fact that we have over 1 million robotics developers. We created Jetson, this robotics computer. We're so proud of it. The amount of software that goes on top of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. Everything that we do in our company is in service of our developers. And by us being able to maintain this rich ecosystem and make it compatible with everything that you access from us, we can bring all of that incredible capability to this little tiny computer we call Jetson, a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor. Most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, or they'd be following APRO tags. But in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, would you like to go from point A to point B? And it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have two modalities to keep an eye on what's happening in the world. Isaac Perceptor. The most used robot today is the manipulator, manufacturing arms, and they are also pre-programmed. The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. So the foundation pose, the grip foundation, and the articulation algorithms are now available. We call it Isaac Manipulator. And they also just run on NVIDIA's computers. We are starting to do some really great work in the next generation of robotics. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots because we are constructed in a very similar way. It is very likely that the humanoid robotics will be much more useful in our world because we created the world to be something that we can interoperate in and work well in. And the way that we set up our workstations and manufacturing and logistics, they were designed for humans. They were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating, just like we're doing with the others, the entire stack. Starting from the top, a foundation model that learns from watching video, examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. And then an incredible computer, the same computer that's going to go into a robotic car, this computer will run inside a humanoid robot called Thor. It's designed for transformer engines. We've combined several of these into one video. This is something that you're going to really love. Take a look.
It's not enough for humans to imagine. We have to invent and explore and push beyond what's been done.
A fair amount of detail.
We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. We broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us. This is where inspiration leads us, the next frontier. This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed ElevenLabs, a robot learning application to train Groot. on Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Give me a high five.
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With ElevenLabs, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
About the same size. The soul of NVIDIA, the intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics Zero, I know, super good, super good. Well, I think we have some special guests. Do we? Hey guys, so I understand you guys are powered by Jetsons. They're powered by Jetsons, little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Come on, you guys, let's wrap up. Let's go. 5 things. Where are you going? I sit right here. Don't be afraid. Come here, Green. Hurry up. What are you saying? No, it's not time to eat. It's not time to eat. Be a snack in a moment. Let me finish up real quick. Come on, Green, hurry up. Stop wasting time. 5 things. 5 things. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software, a new industrial revolution. Second, the computer of this revolution, the computer of this generation, generative AI, trillion parameters, Blackwell, insane amounts of computers and computing. Third, I'm trying to concentrate. Good job. Third, new computer creates new types of software. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams, create these applications. We have a fantastic capability between NIMs, the AI technology, the tools, NeMo, and the infrastructure, DGX Cloud, in our AI Foundry to help you create proprietary applications, proprietary chatbots. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotic. These systems all need one thing. They need a platform, a digital platform, a digital twin platform, and we call that Omniverse, the operating system of the robotics world. These are the 5 things that we talked about today. What does NVIDIA look like? What does NVIDIA look like? When we talk about GPUs, there's a very different image that I have when people ask me about GPUs. First, I see a bunch of software stacks and things like that. And second, I see this. This is what we announced to you today. This is Blackwell. This is the platform. Amazing, amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell, and this to me is what a GPU looks like in my mind. Listen, orange, green, I think we have one more treat for everybody. What do you think? Should we? Yeah. Thank you. Have a great GT. Thank you all for coming. Thank you.